Hello all. In this session, we will see one more problem on the centroid. So here you can see the figure. So the question is, locate the centroid for the plane lamina which is shown in the figure. Okay, first just see the figure. Okay, before that, first you mark the x-axis and y-axis. So as I told in the previous problem, you can take anything as a reference. Like anything means that bottom level as a x or a top level as x, or left hand side as a y or a right hand side as a y. So it's our wish. So here for the convenience, I'm always taking the base as a x-axis and the left side as a y-axis. And one more thing, in the exam or in the question paper, if internals or an exam, if already they have given a reference axis, so we should not change that reference axis. We have to consider that as a reference axis. If they are not asking anything, so we have to mark the reference axis, that is x and y. So here our question is only to locate the centroid for the plane lamina. So they have not given any reference axis. We have to mark that x and y line. I have marked in a different color, so you can see x and y. They are not given this. We are marking this. Okay. So here you can see the figure. Here the question is, please understand the question. Locate the centroid. Just they are asking locate the centroid. We have, so locate the centroid means we have to find two distance, that is x bar and one y bar. Okay, if you just you see, fold the figure and see if any axis the figure is symmetrical, so no need to find the distance, so it will be lies exactly in the middle. If it is not symmetrical, then only we are finding the distance, right? So the given figure, you just fold it in the y-axis like this, it is not symmetrical, and the same figure you fold it in x-axis like this. Okay, just take a paper and write that figure and fold your paper, then you will get to know. So if you fold that figure in the x-axis, it is not symmetrical. So both the axes, they are not symmetrical, so we have to find both x bar and y bar in this problem. In the last problem, in the last session video, go watch that video. There I have only explained about y bar, right? X bar already we know, right? But in this problem, x bar also we don't know because it is unsymmetrical, and y bar also we don't know because it is unsymmetrical. So since the figure is not symmetrical about any axis, we need to locate both x bar and y bar, right? You need to find both the x bar and y bar here. Okay, for this I have divided this figure into two. You can see I've put one dotted line in the middle. So right side part, it is looking like a quarter circle, left side part it is looking as a triangle, right? So we have required formula for both the figures, for both the shapes, right? So here you can go to anyone, that is x bar or y bar. Here I am going for a x bar to find. So what is the x bar formula? That is summation of ax divided by a. So that is our formula. So here we are finding x bar first. So what is the formula? That is summation of ax divided by a. But you are keeping the reference as y. So that is important. If you are finding x bar, y is a reference. If you're finding y bar, x is a reference line. So that one we need to you need to mention here. So summation of ax means, as usual, how many small areas are there? We have two small areas. Left side I'm taking as a1, right side I'm taking as a2. You can take anyone as a1 and a2, it doesn't matter. So here, as per the formula, you have a1 into x1 plus a2 into x2 divided by capital A. So capital A is nothing but both the areas. So that's why I'm writing a1 plus a2. Okay. Here you have to find a1, a2, x1, x2. So a1 is, that is left side, that is triangle and quarter circle. So half into base into height is 3200 mm square, and area 2 is quarter circle. So the quarter circle area is pi r square divided by 4 is equal to pi into r, that is radius. You can see here the radius, they have given dimension of base is 80. So definitely pi into 80 square divided by 4. So 5024 mm square. So area 1 and area 2 is over now. Now x1 and x2, that is most important. x1, I'll go to the figure. X1 means centroid part of the area 1 from y-axis. From the y-axis, from y, keep one y-axis one finger and middle part of the triangle. So that dimension you can see, you have a formula, right? While we have derived the formula for a triangle, that is, if you're coming from apex, it is 2 by 3 into distance. If you're coming from base, it is 1 by 3 into distance. Same thing we have applied here, that is, if you're coming from apex, so here the reference axis, it is start from the apex, right? So that's why you are taking from apex, that is 2 by 3 into 80. 80 is the whole dimension, so you're getting 53.33 mm. The next is x2, from the y line till the center of the quarter circle. Keep your one finger in the y line, another finger in the middle of the quarter circle, and find the distance, that is 80 plus 4r by 3 pi. 4r by 3 pi you are getting if you derive the formula for quarter circle. So that is 80 plus 4r by 3 pi is equal to 80 plus 4 into 80, that is radius is 80, divided by 3 pi is equal to 113.97 mm. So you got x bar. So substitute the x bar, that is area 1, a1 into y1 plus a2 into y2 divided by whole area. Whole area means a1 plus a2. So you're getting 90.37 mm. So I'll go back to the figure here. So the x bar lies 90 point something from y axis. So that much distance you have to measure and you have to put a point, centroid point. Okay, so 90.37 mm we got x bar from y axis. Okay, so the x bar is over now. We'll go to the y bar now. Okay, what is y bar? So y bar formula is summation of ay divided by a. As usual, formula will be a1 into y1 plus a2 into y2 divided by a1 plus a2. So the area as shown in the last one, area 1, area 2 will not change. So only y1 and y2 you need to find. So here I'll come back to the figure. Okay, y1 means keep one finger in the x-axis and one finger in the middle of the triangle in vertically. So that much distance we needed, and in semicircle also one finger in the x-axis and one finger in the middle. So that much distance we needed. So both we have a formula, that is for triangle you're going from base. If you're going from base means it is if you're going from base means that is 1 by 3, and here if you're going from base means that is 4r by 3 pi according to our formula. Here you can see, so if you finding the from the base, if you are finding, so that is 26.6 you will get, and if you're finding the centroid of the quarter circle, you're getting 33.97 divided by area 1 plus area 2. So the y bar will be 31.129 mm. So in the figure you can see the centroid lies 90.37 from y-axis and 31.129 from the x-axis. So this is a way of finding the problem. Thank you.